Okay, I think we also have this stuff figured out for the iTouch. If you want to log in with that sometime today, come and see me and I'll show you how to do that. Which should be good, because then you can check your homework and stuff from your desk. Okay, so my goal today is to do all the 3, 4, and then I guess you guys want to go over the test, so we'll do that. And then that'll be today. And then tomorrow what I would like to do is to give you a pairs assignment that I'm going to make you do. It's going to be on 3, 1 to 3, 4. Just to see where you guys are at. I kind of pushed through chapter 2, and maybe I have to do that, but maybe I should have done some sort of assessment along the way, because the types of mistakes you guys were making in the chapter 2 thing, like, really? Anyways. So there were some grade 11 kind of mistakes there that really shouldn't be there anymore, but whatever. Okay. So slope of the secant line. If we have a curve and we have 2 points, A, F of A, and we have another point, B, F of B, the slope of the secant line is just, well, that's not very slopey, but whatever. M equals F of B minus F of A over B minus A. Slope of the tangent line, same curve, what do we call that? That red line, a tangent line. It's f prime of A equals the limit as h approaches 0 of f of A plus h minus f of A all over h. So that should be reviewed. And then in 3.3, we started to learn the rules about how we take the derivative, right? We have the product rule, the power rule, the quotient rule. And a couple of days you'll learn about the chain rule and all the trig derivatives and all the log ones as well. Okay? So today is just about applying those rules. So, or at least thinking about the rules in a physical kind of way. So average velocity is the total distance traveled divided by the total time. Which of the two statements above does that most like, or most match? Is that slope of the tangent line, or is that slope of the secant? Slope of the secant line. Yeah. Okay. Suppose you drive your car for 2 hours and travel exactly 80 miles. What's your average velocity? Okay, this is great. A grade 8 could do this. Sorry, that's a bit of a shot. Average velocity is 80 miles divided by 2 hours is 40 miles. 1 hour. Yeah. Blah, 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 blah. Instantaneous velocity, the first derivative of the distance function, s prime of t. For ds dt, what is this like? Slope of the tangent line. Okay, so in AP Calculus, the only thing we're interested in is something called rectilinear motion. Motion of a particle along a line. So one-dimensional motion, running forward and backward along an integer line. Really exciting. Yeah, I know. We're not moving in 2 dimensions. We're not moving in 3 dimensions. Sorry, it's really boring. So s of t gives position. S prime of t gives velocity. What does s prime of t equals 0 tell you? No. What does it give you? If you solve this equation, s prime of t equals 0, what does it give you? What? You haven't moved. You are stopped. You have no velocity. You have stopped. Oh. S prime of t is bigger than 0. Moving, okay, you better define what forward means on a number line. Pause, moving in the positive direction. We tend to say moving to the right here, because left and right. Okay, so moving in a positive direction, moving in the right moving to the right. Okay, right, up if we were going to allow our number line to be up and down, sure. No, it's only along a number line. S prime of t is less than 0. Moving left. Or in this case, you guys wanted to use the word down, which is fine. Because nobody throws an average grade 8 left or right. Sometimes we throw them up, and then eventually they come down. Aha. Okay. Example, S of t equals t cubed minus 6t squared plus 9t, and we are moving in feet per second. Ooh. So find the velocity at any time t. So v of t is s prime of t. I'm going to just write it like all three ways you could see the notation. V of t, s prime of t. You would also see ds dt. So take the derivative of that formula with respect to time. The variable is t. Use the power rule. Three t squared minus 12t plus 9. Okay, I was a little scared. Were you guys freaked out that the variable was t instead of x? No, it's just Monday morning and my brain's not on yet? Okay, what is the velocity after 2 seconds? So what I'm saying here is v of 2. I'm also saying s prime of 2. Here's a weird notation that you would probably have never seen before. ds dt evaluated at t equals 2. Those all mean the same thing. They all mean put 2 in for t. What? So 3 times 2 squared minus 12 times 2 plus 9. 12 minus 24 plus 9 is negative 3. Negative 3 feet per second. Going to the left at a rate of 3 feet per second. Yeah. After 4 seconds, so v of 4 is 3 times 4 squared minus 12 times 4 plus 9, 16 times 3. Ugh. Yeah, I can't believe I can't do it. 64? No, it isn't. 48? No. Yes. Is that 48? 48. 3. 52. 12 times 4 is 48. Plus 9. I was going to say it should have the same answer as the next one. So it's got a velocity of 9 feet per second. Positive, going to the right. Okay, when is the particle at rest? So 3t squared minus 12t plus 9 equals 0. Take a 3 out. T squared minus 4t plus 3. Factor that. 3 bracket. T minus 3. T minus 1. Okay, when is the particle at rest? Yeah, there you go. At t equals 3 and t equals 1. When is the particle moving to the right? In a positive direction. Okay, so in grade 11, you would have solved equations that looked like this. 3t minus 1, t minus 0. Change it to bigger than 0. Mr. App, I need to graph a little mini parabola here. A little mini parabola. And it would have x-intercepts at 1 and 3. And I would ask you, where is the little mini parabola above the t-axis? Okay, yeah, but you got to be aware of the whole situation of the reality here. When you say less than 1, you're allowing negative time. So t has to be between 0 and 1 or greater than 3. Do you want it in interval notation, Lucas, or do you want it in inequality notation? Pardon me? Interval notation? So you can start at 0 and you can go up to 1 and you can start at 3 and you go up to infinity. Does that make sense? That little mini parabola, and when are you above? Anybody not comfortable with doing it that way? 0 is included. Because if you put 1 is not included, because it stopped at t equals 1. The parabola is above the t-axis at 0, but what we do is we allow 0 as a time. Well, we're not allowing you to go to the left of 0 because that would be bad. Negative time, the whole paradox of timiness. Does anybody want a different way of looking at it or no? Okay. When we get into chapter 4, I'll show you another way of doing that because this is too much. It's not that it's too much work, it's just I'm lazy and there's got to be other ways of doing things. Okay, so draw a diagram to represent the position for the particle t bigger than 0 on a number line, then find its velocity each time. Does this make sense? Okay, so what we need to do is to put, we're going to put in our graphing calculator, because I am uber lazy, we are going to type in y1 we're going to put the s of t formula, and in y2 we're going to put the derivative formula that we just generated. So t cubed. Mr. Up, you're not putting t in here. Why not? Because you can't. Actually, I can, but I'm not going to show you what that is. Yeah, but it doesn't help. We have to actually change all the modes on our calculator, and you guys wouldn't like this. So I'm not going to do that. 3x squared minus 12x plus 9. Okay, so we throw in y1 and y2, our two formulas. We want our table starting at 0 by the looks of it and going up by 1. So second graph. We want our table starting at 0 and going up by 1. Second table. And now we just got to write these numbers down. So 0, 9. What's the next one? 4, 0. 2, negative 3. 0, 0. 4, 9. What's left? Well, one more, Mr. App. 20, 24. So represent the blah, 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 da, 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 da. Okay, so I'm going to start right here. So I'm going to hit the gas pedal. I'm going to be moving, so I'm going to go in from t equals 0 to t equals 1, I'm going to go 4 units right. Yes? It's going to look kind of loopy because it's really kind of hard to show this. So then at t equals 2, I'm going to have moved back to here. Oops, that's not very good. It's kind of halfway, Mr. Allen. So 1, 2, 3. At 0, we're back at 0. And then 4, we're back to 4 again. And then 5, we're all the way out to 20. So it's kind of fun to actually make you guys model this in a hallway. We all walk backwards and forwards along a line, and we go, oh, that's fun. You guys want to do that tomorrow? You want to? It's kind of fun. It's dorky. You guys interested? Okay. Okay. Find its velocity each time. Okay, now on the other graph, we're going to do our velocity time graph. So at time t equals 0, we have a velocity of 9. No, where are we going to put 9? 1, 2, 3, 2, 4, 6, 8, 10. So a velocity of 9 at t equals 0. At t equals 1, we have a velocity of 0. At time t equals 2, we've got a velocity of negative 3. 2, 4, negative 3. At time 3, we have a velocity of 0. At time equals 4, we have a velocity of 9 again. And t equals 5, we've got a velocity of 24. Hey, does that graph that I just drew kind of match the little 10-second sketch I did for the previous question? So this is v of t and t. No, the other way around. Does it make sense? Well, there's all of the... Yeah. Yeah, the number line is a position kind of representation of what's going on. Can you see why I kind of stacked the first 4 movements? Riley. Which dot? Which graph? The position graph or the velocity graph? At time. So tell me when to stop to moving the eraser. This one? Well, at t equals 0, our velocity is 9. So it's like a sprinter in the starting blocks, right? Just as they pull the gun on the trigger, they've got a velocity of 9 feet per second or meters per second or whatever our units happen to be. Well, we've done the distance time graph. Well, I guess no, we didn't. Did we? We should do a distance time graph. So a distance time graph would look like this. T equals 0, or S of t would look like this. S is 0. At t equals 1, S is 4. At t equals 2, S is 2. At t equals 3, S is 0. At t equals 4, S is 4. And t equals 5, S is 20. Well, I don't know, up here somewhere. Yeah? Okay, what is displacement, physics people? What? So at the 5-second mark, how far are you from the beginning? You're 20 meters from your starting point. 20 meters to the right of your starting point. Or 20 feet. 20 feet to the right of starting point. Okay. What is the average velocity in the first 5 seconds? Divided by 5 equals 4 feet per second. What? No. Average velocity is the slope of the secant line. What we're actually saying here is to join this dot and this dot with a line. What is the slope of that line? That is the secant line. Average velocity means secant line. I, what is the total distance traveled in the first 5 seconds? Okay, Garrity, we're going to add. Actually, we're going to move along the line. From here to here, how far did you move? 4. From here to here, you moved? So 6 total. From here to here, 8 total. From here to here, 12 total. From here to here, 16 total, 16 more, so 28. Traveled a total distance of 28 feet. Sometimes you consider motion on a vertical at what? Yeah, I guess you could. This graph. Yeah, well, 0 plus 4. No, that wouldn't work. Because the left-hand motion here from 1 to 2 to 3 isn't accounted for. Like if you go at 4 plus 2, you'd get 30 if you did that. So what? So I didn't count anything. I went from here to here is 4, plus 2 more is 8, plus 4 more is 12, and then I'm at 4 units, and I go to 20 units, so I go 16 more. Yes. Yeah. Okay, so sometimes moving up and down can be done with this, and we're going to do that right now. So we take your average grade 8, and you put them in, you take them to a tall building, and you give them a push in the upwards direction. How fast is the grade 8 moving at time t equals 0? So S prime of t equals negative 32t plus 96. S prime of 0 equals negative 32 times 0 plus 96. 96. So he's moving up at a rate of 96 feet per second. What is the height of the ball when the velocity equals 0? Oh, so we need to find when t equals 0. So S prime of t equals 0, negative 32t plus 96 equals 0. T equals negative 96 divided by negative 32, 3. So the ball is stopped at t equals 3. How high is the ball? What's that? Does this have an incredible sense of physics 11 to it? Good. Oh. Good. 700 and what? Thank you, because it was painful for me to type it in. Feet. So that little grade 8 goes 784 feet in the air. What? Gravity's there. See that negative 16? G for gravity in feet per, in units of feet in second is negative 32 feet per second. Gravity's there. Because it's an American test as well, you have to be able to, it's the same process. No, I don't ask you to convert feet to, and I haven't seen the exam convert. If it's all in feet, it stays in feet. I'm not asking you to convert feet per second into yards per second. Okay. Yeah, he's reached the highest point, right? So you take your average grade 8 to the top of a tall building, and you chuck him up in the air, and you have to realize that I'm stretching time out, so it doesn't look like this, but it looks like that. So what I'm asking you to do is to find when your tangent line has a slope of 0. That's what this is doing. What is the velocity of the ball when he returns to Earth? So what I'm doing now is talking about this point, and I want to know the slope of this point. So you got to figure out when he hits the ground first. So negative 16 t squared plus 96 times t plus 640 equals 0. Mr. Epp, all these numbers are divisible by negative 16. Divide everything by negative 16. I will try and set them up so that happens. Yes. Well, I don't know. Sometimes I am. So divide everything by negative 16. So you get t squared plus, divide everything by negative 16, dude. Make your life easier. 96 divided by negative 16 is negative 6. 640 divided by negative 16 is negative what? No, it's the same thing. What two numbers multiply to 40 and 8 and 2? 8 and 2. So negative t minus 8, t plus 2. Does the negative 2 make sense to you? Look at the graph of the building. What? 7 and 4. What? 10 and 4. I don't know. Good drugs. I don't know what I was doing. Bad drugs. Does that make sense to you on the graph now? Because all you're doing is extending this graph back and it touches at negative 4. And it doesn't exist there because you can't go back in time. So, what is the velocity of the ball when he returns to Earth? Grab the velocity formula. S prime of t equals negative 32 t plus 96. Put 10 in for t. Negative 32 times 10 plus 96. Negative 320 plus 96 is what? Negative 224. Watch out, because that kid's cooking. Get out of the way. Tennis ball, right, it's a tennis ball. It's not a grade 8. We're not allowed to drop grade 8s off of tall buildings. That's Mythbusters. Nothing. It'd hurt. No. No. No, it wouldn't kill you. It just hurt. No. Yeah, it'd hurt. Speed. Speed. The absolute value of the velocity is speed. Acceleration is the rate of change of the velocity, or the second derivative. We could have also written it as d squared s over dt squared. Okay, a dynamic blast. You take a grade 8 and you put them inside of a cannon and you fire it straight up with a launch velocity of 160 feet per second. It reaches a height of s equals 160t minus 16t squared feet after t seconds. How high does the rock go? What do we got to do? So, here's the picture. I want to find this point. Tell me about the slope right there. So we have to, how do we find slope? Derivative. Slope there is 0, Mr. Up. What does t equal? What? T equals 5. I took the derivative. You didn't see that. So at t equals 5 seconds, the rock is at its highest point. Apogee. Move the 160 over to the other side of the equation. Divide by 32. Negative 32. Okay. So that tells us our t coordinate. How do we find our s coordinate? Take the time t equals 5 and put it in where? Into the original formula. $160 times 5 is what? Well, 800 is the final answer. Oh, that one's 800. 5 times 5 is 25. 16 quarters. 400. So 400 feet in the air, that grade 8 will go. Well, 40 stories. Yeah, maybe less than 40, maybe 30 stories. So taller than any building in Kamloops. Watch out. Okay. So that's A. B. What is the velocity of the speed of the rock when it's 256 feet above the ground on the way up and on the way down? The velocity? No, when I teach grade 8s, I make fun of grade 12, so it's, I do. I do too. Not in a long time, no. So there are 2 points here and here that are 256 feet above the ground. What I'm asking for is the slope there and there. Can anybody make an argument, even though that my drawing here is really crappy? The slopes are going to be the same but opposite in sign, S-I-G-N. So all we really need to do is find one of them. So we need to know when we're 256 feet above the ground. So we take our formula, 160t minus 16t squared equals 256. Change it into something our Math 11 teacher would be proud of. Smile and say, Mr. Epp, thank you for making everything divisible by 16. Thank you, Andrew, for thanking me. So factor out a 16 or divide everything by 16. You get 0 equals t squared minus 10t 16 times 16 is 256. Eight and 2. There's the 8 and 2. Knew it was in here somewhere. T minus 8, T minus 2, at T equals 8, and T equals 2. So we can find S prime of So on the way up, so S prime of 2 equals 160 minus 32 times 2 is 160 minus 64. 96 feet per second. What's T equals 8 going to be then? Don't do the calculation. Negative 96. ABC. What is the acceleration? Acceleration is the second derivative. S double prime of T. So start with that and then take its derivative. 160 minus 32T. Negative 32. And you're done. Because put T equals 5 in, please. Negative 32. Put T equals 26 million in. Negative 32. Oh, right. Gravity's constant. Right? Pardon me? Would you like to change gravity? You mean what I went from here to here? Okay, what's the derivative of 160? 0, it's a constant. There's a power of 1 up here on the T. Put a minus sign down, copy the 32, take the yellow 1 down, T to the power, take 1 away from the yellow 1, you get 0. Anything power 0 is 1, my friends, not 0. Don't because it's a constant all by itself. Sure, but think about it. Just 160 is just a single solitary number. The derivative of a constant is always 0. Always 0. I mean, I can make it really complicated. Just a sec. I need to get excited, and I need to put this down here because this is something silly that kids do over years and years and years. So S prime of T equals pi E squared times 56 factorial divided by, I don't know, let's put another constant, the speed of light squared. What is S prime of T? 0. That's just a funky constant. Really exciting constant, but the slope is 0. Okay? Okay, there's no, Mr. Up, we got to use the quotient rule because you're dividing. 0. They're all constants. Okay? You got to use the quotient rule and the product rule because you're multiplying. Okay? Okay, you know what? D, when does the rock hit the ground? Well, 160t minus 16t squared equals 0. Have we done this before? The rock hits the ground at t equals 0. and t equals 10. And then we'll stop for this part and we'll finish. Unless you just want to keep on going. What? Yeah, you get this many. This many. You get this many formulas. This many. On the AP exam, you get this many formulas. This many. There is no formula sheet. I don't know, how many are you up to now? Okay, see if you can do this one now. What is the velocity at t equals 1? What is the acceleration at t equals 1? When is the particle at rest? Another way I could ask you is, when does the particle change direction? Yeah. So, what is the velocity at t equals 1? Well, we need to figure out the velocity formula. S prime of t equals plus 8t minus 3. What's the velocity at t equals 1? S prime of 1 so 3 plus 8 minus 3 is 8 feet per second. Okay, S double prime. No. 6t plus 8. What is the acceleration at t equals 1? S double prime at 1 equals 6 times 1 plus 8. 14 feet per second squared. When is the particle at rest? When its velocity is 0. When it changed direction. So 3t squared plus 8t minus 3 equals 0. So what two numbers multiply to negative 9 and add to positive 8? Negative 1 and positive 9. So 3t squared plus 9t minus 1t minus. So the particle changes direction or is at rest at t equals 1/3 and t equals negative 3. Lucas. Yep. 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 You could graph it too. Just do the 0 command, right? Whatever floats your boat, man. Okay. Consider the position function s of t equals t cubed minus 6t squared. Find v of t, a of t, and graph them. Use the vertical scale between negative 40 and 60. So, graphing calculator. T cubed minus 6x squared. Window 0, enter. Try that again. 0, enter 8, enter negative 40. We all have that picture on our screen. Zero, 8, -40, and 60. Oh, did I put a... Oh, I need a 6, you silly rabbit. Okay, now does it look like what you've got on your screen? Okay, so draw that on your first box. Take note where the curve cuts through the x or the t-axis. Also take note of where it's got a nice flat bottom. y1 equals t cubed minus 6t squared. Okay. Yeah, So I am asking you to take note of where this point is. Just put a circle around it or something. Why is F interested in that point? Zero slope. That's where it starts to change direction. Did you notice that? He's moving left, or lefter, starting to go to the right now. And then that's on the right-hand side of the zero, the number line. So you could take that and make it look like some sort of animation of a guy running along a number line. He's running along to the left, stops, turns around and comes back, and really starts to move. Yeah? Little flash animation for us. Put it to music, it'd be awesome. Okay, next one, take the derivative. So 3t squared minus 12t. Three t squared minus 12t. Okay, you don't have to have it in y1 and y2. I'm just doing it so we see the new graph each time. Now, why was Mr. Epps so interested in that yellow point on the previous graph? Well, that point is now here on the derivative graph. Yeah? That's where the slope equals 0. That's where the particle is changing direction. But it makes sense. I mean, that's... Okay, I want to put a blue dot right here. Take the derivative again. y1 equals 6t minus 12. That's where the slope is constant on where the slope is 0 on the derivative graph. On the derivative of the derivative graph. No, wait. Slope is 0 on the velocity graph. What do we call that, physics people? Constant acceleration? You're not accelerating or decelerating? So velocity. So if you're driving in your car, your speedometer would be set at 50 kilometers an hour and it wouldn't be moving right now. On the third graph. No, right here you're not accelerating or decelerating. You're still moving. You're moving at a constant velocity. Then you're accelerating again. No. Okay, so velocity is bigger than 0, you're moving to the right. Velocity is less than 0, you're moving to the left. Velocity equals 0, particle stopped, or particle is changing direction. So, like a bug on a wire, do 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 do. Except for you don't too young to even know that song. Like a bird on a wire. Okay. Why do you use the bird there? Well, the bird can fly off the wire, silly. Okay, anyways, bugs crawling along a straight wire. The velocity v of t of the bug at time t equals 0 to 11 is given in the graph below. According to the graph, when does the bug change direction? There's only one time that the bug changes direction. This is velocity time. So you need to watch and be careful. The velocity v of t. So we're looking at v of t versus t. At t equals 8. Good. The bug is changing direction. B. At what time t is the speed of the buggy the greatest? 10. Good. Why wouldn't you say 2? Good. Speed is absolute value. C. When is the bug moving to the right? Right. 0 to 8. When is the bug moving left? 8 to 11, or at least... No, it's still moving right, left. Because we don't know. Could be doing this, could be doing this, could be doing this. Depends on how long the wire is. So left, we would say from 8 to infinity, maybe. That's right. Yeah. Library. Yeah. Overhead bulb. Ooh. No, I won't say it. We all are, Mrs. Wolfram. We all are. Okay, find the instantaneous rate of change. Okay, you read this phrase. Instantaneous rate of change. Velocity is the instantaneous rate of change of position. So I'm asking you to tell me the instantaneous rate of change of the area. Strap. You're just asking for the derivative. So the formula for the area of a circle is pi r squared. So I'm asking you to tell me the derivative of the area function. So dA over dr, you could also write it as a prime. It actually makes sense to write it more as dA over dr, because you know what the variable is then. So pi is a constant. Everybody write the pi symbol down, put their thumb over it. What's the derivative of r squared? 2r to the 1. So we get 2 pi r. Hey, Mr. App, as you increase the area, what has to increase? The circumference. Oh, beep, 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 beep. We're backing up. Y equals 5x squared. What's the derivative, please? Y equals pi x squared. What's the derivative? 2 pi r. Now, you want to use overkill? Here's overkill. We all remember the product rule. We practiced it this past week. So, product rule. Get rid of that. Get out. Go away, stuff. I don't want that there anymore. Okay. So, y equals 10x squared. So you could say, if you were really crazy, the first is 10. The derivative of the first is 0. You could then say the second is x squared. The derivative of the second is 2x. So if you want to do y prime and put it in the formula, Oh, I drink coffee. No, I'm good. Can I give you something? So, oh, I don't know. So you could technically do this. And you get the same answer, yes? But do you agree that that's not overkill? Overkill? So, you could do that. You could say u is pi, u prime is 0, v is r squared, v prime is 2r, and when you use the product rule, you end up getting 2 pi r. So, like, why overdo it? That's my point. So, evaluate the rate of change at r equals 5 and r equals 10. Oh. So, a prime at 5 is 2 pi times 5. A prime at 10 is 2 pi times 10. Twice as big. If r is measured in inches and a is measured in square inches, what units would be appropriate for dA over dr? Well, I don't know. I want to know how fast the area is increasing divided by how fast the radius is increasing. Wouldn't it just be square inches per inch? Don't cancel. Don't cancel units. Square inches per inch. I know. Pardon me? And use centimeters? Yeah. Well, that's why the circumference is measured in inches. But its circumference is just how fast the area is changing. No? No? That doesn't bother you? It kind of makes sense? Okay, put a line. Just put a line. What's the formula for the volume of a sphere? It's 4/3 pi r cubed. What's the derivative of 4/3 pi r cubed? Well, copy down the 4/3. So the derivative, copy the 4/3 down, Mr. App. Put your thumb over it and say, what's the derivative of r cubed? 3r squared. What happens to the 3's? What do you get? 4 pi r squared. Anybody recognize that? Surface area. So as you blow air into a balloon, you're increasing the volume, are you not? Well, when you increase the volume of the balloon, don't you have to increase its surface area? Cool? Coincidence? Nope. Not at all. No, derivative is changing. No, it's not. Don't worry about dimensions. Derivatives just say how fast is something changing with respect to something else. Right? So as I change the volume, what else has to change? Surface area. As I change the area, what has to change? Circumference. Or perimeter, right? Like if we want to use a grade 8 thing and talk about a rectangle, and as we increase the length and width, what also, as we increase the area, the length and width has to change, right? And if the length and width change, the perimeter has to change. It's one of those duh moments, right?
Okay, the last page is optional. Do you guys want to talk about business stuff? Or no, it's not assessed in AP. I usually do it as for those students who want to study business at university. Yeah, don't worry about it.
Okay.